let's say we do a case control study with 50 lung cancer patients and 50 controls, and we find 40 smokers in the case group versus only 10 in the control group.
We went out and we found 50 lung cancer patients and 50 controls without lung cancer. So we cannot say anything about the risk of lung cancer from this case control design.
Exactly. We can't say anything about risk. We can't say anything about risk ratio. But we are allowed to calculate a very specific odds ratio here. We can calculate the odds ratio representing the increased odds of being a smoker in cases versus controls. And that turns out to be 16 here. And that means cases have a 16-fold increase in the odds of being a smoker.
But it's backwards, Kristen.
Yes.
So I don't really want to know, okay, if someone has cancer, what were their odds of having been a smoker?
Right. Yes,
What I want to know is if someone smokes, what are their odds of going on to develop cancer?
Exactly. So here's the really cool part. Odds ratios have this amazing mathematical symmetry. And it turns out that this odds ratio for smoking in cases versus controls, which is valid to calculate from our sample, that is actually mathematically identical to the odds ratio for lung cancer in smokers versus non-smokers. So we can conclude not just that being a case increases the odds of smoking 16-fold, but also that smoking increases the odds of lung cancer 16-fold.